Okay, students, let's proceed. You are asked here to find the modulus of the complex numbers z equals 1 plus 3i over 2 plus i. So how can we find the modulus of this complex number? Just recall the property how you can find the modulus of the complex number given in terms of ratio form. So what you need to do is the following one. Okay, so the solution goes like this. We know that the modulus of a certain complex number z1 over z2 is going to be the modulus of z1 over the modulus of z2. So 1 plus 3i over 2 plus I modulus is 1 plus 3i modulus, 2 plus I modulus. And this is going to be the same as the square root of the real part squared plus the imaginary part squared. So 1 square is 1 and 3 square is 3, 9, and here you see the real part is 2, so you need to square it. Okay, this is again for students. I'm mistaken here, please correct that. Here the real part is again the imaginary part is 1 square it will be 1. So this is going to be what student? This is 1 plus 9 is going to be radical 10, but have a correction here please. 4 plus 1 it will be 5, radical 5. So finally you will obtain this to be radical 2, students. Please have a correction, students. Have a correction here. This is radical 2, not radical 30 over 3, student. Please check it. It will be radical what? Radical 2, because radical 10 over radical 5 makes radical 2. Here I didn't square it, that's why the mistake has been, obtained here. So please have a correction. The answer is radical 2. Now proceeding to question number 20, it says consider the polynomial function this. So you are asked to find the zero of this with its multiplicity, and you are also asked to write this in terms of product of linear factors. So very simple. So what you need to do is first you have to find the integral factors of, you see, the constant term and the leading coefficient. Remember ratio test. So this is your constant number 2. So the integral factor for these integral factors are plus or minus 1 and plus or minus 2. So have them as you see, and the coefficient here is 1. So the integral factors for 1 are plus or minus 1. So plus or minus 2 divided by plus or minus 1, or you see this plus or minus 1 and plus or minus 2. So you are having here 4 different possible integral zeros. So we are going to substitute these values one after the other here in place of f. So here I begin from minus 1. So when you substitute minus 1 in f, it will be 0 as you see. Minus 1, it makes this 0. And again, if you substitute 2, again, you see it makes 0. Once you know these two, the rest can be easily obtained by using factor theorem, right? So if minus 1 makes 0, x plus 1 is a factor. If 2 makes 0, x minus 2 is a factor. So x plus 1 times x minus 2, now the product can also be a factor. So this is a factor of f. So in order to determine the rest, we have to divide this given expression by this x plus 1 times x minus 2, and this makes x squared plus 2x plus 1. Student, please do it. Just apply long division method and divide this expression by the product of these two. You will obtain that to be this, and this is basically x plus 1 the whole squared. Thus, students, this function, the long function, the polynomial function with degree 4, can now be written in terms of what? Binomial products, as you see, x plus 1 times x minus 2, x plus 1 the whole squared. So clearly the zeros can now be obtained with zero multiplicities. So x plus 1 cubed x minus 2, so clearly the zeros are minus 1 and 2. So the zero for minus 1, the multiplicity for minus 1 is 3, and the multiplicity for number 2 is 1. And how do you write this as a linear product of linear factors? You can have this one. This x plus 1 is written 3 times, x plus 1, x plus 1, x plus 1, and then x minus 2 can come at last. This is how it is done, okay? So when we proceed to the next one, we do have question number 23. So it says, find the general form of the equation of the tangent line to the circle x squared plus y squared plus 6x minus 2y minus 7 equals 0. at the point p minus 2, 5. So what you need to do is the following one in order to find the equation of this tangent line. So the solution goes like this. First, we have to determine the center of the circle. Okay? So to find the center of the circle, what you need to do is just take the equation of the circle as you see. Now what follows is, you see, try to collect like terms together and number to the right side. So this comes because half of 6 is 3, square is 9, half of 2 is 1, square is 1, and then 9 and 1 are added. So you need to add these two on 7. And next from this, we are having x plus 3 the whole squared plus y plus 1 the whole squared equals 17, because you see the sum of the square of this makes this one, and the sum of the square of this makes y squared 2y plus 1. So when you add this, you do have 17. So clearly, the center for this is a point having coordinate minus 3 and minus 1. And the slope of the line segment from the point of tangency minus 2, 5 up to the center is going to be like this. Just to find the slope, changing y over changing x. That is to say 5 minus minus 1 over minus 2 minus minus 3, and it will be 6 over positive 1, which actually is 6. So this is slope of the line segment. Okay, the slope of the line segment from the point of tangency up to the center. So clearly, since the tangent must be perpendicular to this, it has to have a slope having minus 1 over 6, because the product must be negative 1, because one is perpendicular to the other. So if we are having a slope of a line being negative 1 over 6 and a point where the line can pass through minus 2, 5, so you can determine the equation of the tangent line by using this equation. Y minus y1 is equal to the slope into x minus x1. So the slope is negative 1 over 6, x1 is minus 2, and y1 is 5. So plugging all this in our equation here, we can obtain y minus 5 is equal to negative 1 over 6 into x minus minus 2. So this is going to be finally y is equal to negative 1 over 6x plus 14 over 3. So students, this is going to be the equation of the tangent line to the circle at the point of tangency minus 2, 5. I hope everything is very simple, right? Now comes the workout part, students. Here we do have also certain questions, so let me show you how it can be done. Question number 24 says you are given a certain argument, so you're supposed to identify whether this argument is valid or not. And we know that an argument is valid if the conclusion comes what? True for all assumed true premises, okay? So first we have to write this mathematically as follow. Using mathematical symbols, we need to write this one. So let's proceed. Let me show you how it can be done. First, you have to identify these statements. Have P to be the economy prospers, so make that to be P, and then take Q to be the other one, unemployment false. And then you do have also another statement there that's talking about GDP. So GDP rises. Look, everything is now, you see, written. So next in the next sentence, use these three statements, so we don't need to use other denotation. So, but unemployment is not falling or GDP doesn't rise. So in the case of this, we have the following logical argument form of writing. So look how it is written. This is written as if, then, so implication must be used. But in between there is P, so directly P is used. Here unemployment false or GDP rises. So unemployment false is directly Q and GDP rises P, R. So this directly comes being like this. Now unemployment is not falling. So negation Q is going to follow, or disjunction comes and GDP doesn't rise, negation R follows. Therefore, that is to say, as a result, the final one, the economy doesn't prosper. That is to say, negation of P. So you are going to identify whether this is valid or not. So to do that, first assume that these two are true, and then check whether the last conclusion is true or not. So for this, you need to prepare a truth table, as you see. So I'm using now 8 possible rows because I'm having 3 propositions. To the power of 3 is 8. So if you see you see everything is labeled as you see. So as it has been stated here, you see our arguments is having these premises. P implies Q or R, here it is, and negation Q or negation R, here it is again. So for these two we are having truth value true for in the second, third, 6th, 7th and 8th rows. But if we are able to obtain, you see, truth value true for negation P for all these rows, we can say the argument is valid. But if we do have at least one if in one of these rows, it will be invalid. But if you check the second one, student, later on the address, if you check the second one, negation P is false. If you look at the second one, these two are true, the premises are true, but if you come to negation P, it will be false. So this shows you that the argument is invalid, okay? So the argument is going to be invalid, okay? This is how you can just verify. I hope everything is very simple for you. I hope you have understood.